Hello students, welcome back. We went through an example on implicit differentiation. Let's have some more. So previously, let's go back to previous example here. This is what we want, and we can take the derivative implicitly. What's the technique? Derivative of x cubed by x 3x squared, no problem. Derivative of y to the fifth power by x, well, apply the derivative formula to y, and then y prime pops up. Here, product rule, the derivative of the first function, x squared, becoming 2x, no problem because it's an expression of x. Y cubed becoming 3y squared if you take the derivative by y, but whenever you take the derivative by y, y prime pops up. And make sure you have those y prime whenever you have derivative by y. That's why I'm highlighting those in red. Keep those in your mind, and then let's have these derivatives. Okay, all right. Let's rewrite the problem. 3 squared, let's keep it as 9 and 4. And then fractions, so a little bit bigger font. All right, let's begin. Let's take the derivative by x, 2x, and then 1 over 9, so 9. Oops. All right, and then 2y, if you take the derivative, 4. Did I do this right? No. I took the derivative by y, so y prime pops up. All good? Nope. Right hand side is a constant. If you take the derivative, it becomes 0. Both are common mistakes. Forgetting y prime, that's a big mistake. So half the credit gone. Actually, excuse me, in this case, we have only one y prime here, so all credit will be gone there if you miss y prime there. But if you have multiple y prime there, there are 4 y primes supposed to pop up, but you missed just one out of 4, still half the credit will be gone because y prime is that important. And then forgetting this constant here, 1 becoming 0, won't be too bad. 1 point, maybe 2 points, depending upon what the implication is. Anyway, we got that. Now let's solve for y prime. Well, okay, all right. Let's simplify a little bit. That's 1 over 2. And this one will have to stay the same. Okay, all right. 1/2 y and y prime is equal to, let me keep highlighting in red, negative 2/9 and then x. Okay, all right, and flip away all these. Y prime is equal to, let's keep this red, and then multiply away 2, so 4/9, negative 4/9. But then again, I have to divide away y. That's gonna be my answer. Same computation, right? Never mind about these. Let's see. Let me copy and paste this thing here. Some people may want to do it this way. What's the difference? Technically nothing, but this dy dx notation just intimidates students, so I generally avoid it. But almost all textbooks exclusively use dy dx notation. Almost all computer algebra systems exclusively use y primes. So depending upon your preference, if you're a computer person or if you're a textbook person, choose your favorite method. Okay, here's another problem, Descartes volume. Well, do you want to try? Stop the playback and do it on your own. Okay, let's take the derivative, 3x squared, no problem there, 3y squared, and then y prime, don't forget y prime there. Whenever you take the derivative by y, y prime pops out. And then what you have is a product rule, 2x times y. So derivative of the first function is 2 times y. First function is 2x times derivative of y. What is it? Just y prime, isn't it? Or if you take the derivative of y by y, that's going to be 1. And then times y prime pops up. You can do it this way too. Derivative of y is y prime directly, you can do it that way too. Or take the derivative by y becomes 1, and then y prime pops up. Either way, it's going to be the same thing here. Okay, alright, we have two y prime terms, 3y squared y prime minus 2x y prime, and then let me highlight those in red. Y prime is the most important factor here. And then everything else to the other side. 2y was there before, 3x squared. Okay, and then I've factor out y prime, 3y squared minus 2x, 2y minus 3x squared. And then finally, y prime is this one, divided by this. What do you think? Did I do this right? Does it fit your computation? Well, what did I do here? Oh, here, okay. I use dy dx notation. That's a bit too big. This one, let's expand just a little bit. Okay, let's compare. And first, same answer, so I must have done it right. How about this? The same computation. Whenever I take the derivative by y, I have dy dx popping up. Same as y prime. Here, dy dx popping up. All dy dx terms in one side, everything else to the other side. And factor out dy dx. So we had two dy dx's here, still two, but one side. Now I have only one. If you have some leftover dy dx in the right hand side, it's meaningless. You have 3, you have 4, you have 5, all those dy dx's have to go to the left hand side. All the others to the right. And then factor out. If you have some just lone terms out there without this derivative, then you cannot factor. So everything has to move to the right. Factor and then divide. Yep, same thing we did before. So do you like prime or do you like dy dx notation? Me personally, I prefer me personally, I prefer y prime notation. And students usually score better with y primes because they are simpler, but dy dx. That's totally fine with me. Okay, we're done with the implicit differentiation, at least the first step. I have some time left, but second derivative, those are, Okay, let's talk about the second derivative just a little bit, because these problems are almost useless in terms of exam preparation, so I don't want to overemphasize it, although there's no justification to throw away everything simply because it's less likely to appear in the exam. But anyway, after taking the derivative, this is the first example we did, so in 1.2, we went through the very same problem and calculated the derivative. And then if you take another derivative here using the quotient rule and product rule and chain rule, you're going to get the second derivative. That's basically it. So what do we have here? Second derivative, derivative of numerator. And when you take the derivative of numerator, whenever you have y coming up, taking the derivative and the y prime pops out. And then derivative of denominator, the same philosophy applies. And then we have this expression. So that's the second derivative. And then y prime is this fraction. So plugging in that fraction in place of this y prime, here, here, and there, as you can see, you get y prime computation completed in terms of x and y. What do you think? It's an easy computation if you look at step by step, but extremely tedious. And then if you're human, if you try to follow, at some point you will make mistake. So this is a kind of problem that is almost useless for exam preparation, but for some homeworks or something, I could consider. And that's why I de-emphasized this section in gray. But anyway, second derivative, you can do it like that. And we have an example problem associated to this. I'll leave that to you. Okay, we completed section 1. The important part, of course, is the review and exercises on implicit differentiation. And as for the second derivatives, well, do not overemphasize it. Okay, all right. You should be able to do some computations because everything there is associated to the use of product rule, quotient rule, and chain rule, and you should be able to do those. But in practice, almost useless. I'll throw away almost. It's useless in terms of exam preparation. For others, almost useless. For exams, totally useless. Okay, so much for section 1.